Hi, today we are going to write a program for factorials. The logic for factorial is very easy. Let's get straight into it. So, what if you require a factorial of say a number, say 5? Okay, what factorial does is that you need to find the sum of 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 till 1. So, in this case, it will be, if we say, so this is the factorial. If you say, no, I've used the function to actually do that, but you can do it orally also. 5 into 4 is 20, 23 is a 60, 62 is a 120 into 1. Okay. So if you say 5 factorial, it will be 120. So similarly, if you want to go for 6, you just multiplied this by 6, it will become 720. And this should give you 720. So this way you can generate your factorials. Right. So now let's just program it. So let's get straight into it. We'll create our program in Eclipse. If you want to know how to create a program in Eclipse, we have put a previous video for this. If you want to run through command line, we have put a video for that also. Please check out our previous videos. So we'll say new class. We will name it Factorial. So this program we are making without recursion. So as we have, our main method has been generated. Now let's first write our algorithm in English. Algorithm for factorial. Now if we are saying factorial of a, it's equal to a multiplied by a minus 1 multiplied by dot 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 till 1. So that is the definition. Now if we say a input is equal to is the input, so logically we'll write next step will be, if we say factorial is being stored in f, it will be f into a, this first step. Next line it will be a is equal to a minus 1. Next step will be f into a again. And no, we can just go back to the previous step. We can leave loop on, and this is the logic. Let's write it in English. So the first step will be a is the input variable whose factorial we have to find. Next line, initialize f which has to store value of factorial. Number 3, if value of a is less than 0, f is equal to 0. Now, if value of a is equal to 0, then f is factorial, f is 1. So this is the logic. If it's a is equal to 0, f is equal to factorial is equal to 1. Why? So you can read the definition. You have to decrease the value of the number till 1, keep on multiplying it, so you get the factorial. If it's 0, if you have to find out 0, you decrease it to 1 and you multiply it by 1 and you get the value. Read it in. Now if value of a, we'll say run a loop for a number of times. So we put it in small apostrophe because we are using it a as the variable and a can be misinterpreted. Now we'll say f is equal to f into a. We'll say a is equal to a minus 1. Now we'll say continue loop five to 8. We'll put the line numbers. And just print value of f. and we'll say go to step 9, go to step 9. So this is the algorithm. Let's just decrease the size a bit. So we'll just put a condition also over here. If value of a is more than equal to 1, continue loop. Okay. We can remove this, though it makes sense, but as we have put this thing in line number 8, we'll use that. Looks good. Now we'll write this program. Actually, if you see, a factorial of a negative number is undefined. We are putting it as 0, but will not program this, which will not be correct. Will actually exit at this point. Okay. Will not be printing that value. We'll just say exit. So let's start writing our program. As we don't write anything mostly in our main method, we'll create our function. So we'll say public void find factorial. We'll say int I input variable. Now we'll initialize I factorial is equal to 1. Why 1? So that when we run this line number 6, it can give you the correct result. First we'll say if, and we'll say input variable is more than equal to 0, then only get into this loop. Else it will exit by default. Now we'll say if I input variable is equal to 0. Now though we have initialized it equal to 1, we don't really need to do anything, but we'll just make it equal to 1 explicitly. Now we'll say else now what we'll do in this one is that we'll run a do while loop. Why do while? Because we want to solve it with something else. We can use any other loop to perform this thing. So this I do. First we'll write that condition. So our loop has come. We'll have to just write the condition over here. While I input variable is more than equal to 1. Okay. We don't need this. Sorry. Now here we will write a logic. Now factorial is equal to factorial multiplied by input variable semicolon. Now the input variable minus minus, it's same as I input variable is equal to I input variable minus 1. And once this loop is over, system not out the print the so we'll print the factorial over here. Factorial is equal to, put some space, put a plus sign. It's a factorial. Okay. So if I factorial is less than 0, anyways, the factorial is undefined. Good. Let's just run it. So we'll initialize the object. And we'll put as 5. Alright. Let's just run it now. Actually, first we'll have to build it. So factorial is equal to 120. Now this is looking a bit misleading. It's not giving complete information. So what we'll say, 90 I duplicate input variable is equal to input variable. Just bear with me for a second and you'll know why I'm doing this. We'll go down and we'll say factorial of plus sign, again a plus sign, give the space, will look better. We'll say project and now we'll run this. So it looks much better now. Let's try for another number. Okay. What we have done in last step can be done in a much better way. So we, instead of Going from this point, we'll write another function to call it so that we don't have to make a duplicate variable. Public void that one is find factorial, say get factorial. It will have the same input variable. And what we'll do is that we'll put this condition over here. Just find factorial over sin t I factorial is equal to find factorial. Now you can say of I input variable, that will be fine. And now we'll say system out the print ln. Actually, we'll copy this line and put it over here. And we'll say input variable over here. It's giving you an error that you cannot change from void because this function does not return anything. Let's rectify it. Just make it int. And at this stage, we'll say return I factorial. Okay. What this does is that it eliminates the need of a duplicate variable. Okay, we can make this function private. You can let it be public. So there is something else it can do, that we can actually expose only this function, and implementation we have put in another function, and this area we have to just remove the system of and we don't need this, and this area can be used for multiple purposes. The main use of this function is just to compute the factorial. What we do with the factorial is being done by the upper function. Now let's just run it. Why we have put this condition over here? Because there is no way we could have not returned something for I input variable is less than 0. So we have to change this to get factorial. Let's run it now. Okay, now let's make it 6. Now we'll run it in Java limitation. That's 720. Let's see what happens in case of 0. And if we say -1, what will happen? So nothing happens over there. Now, there is a limitation to this. What happens is that if you put in a big number, say 16, because the value of 16 factorial will be so huge, the int will not be able to store it, and you will get a weird answer for the weird output for this. Okay, 16 is working. Hopefully that is the right one. Let's try 20. So you can see it's giving you a negative number. One way to solve this is, let's solve this. We'll make I factorial as a float. Okay, nothing much is required. We'll just change the float. Sorry, not float. Let's make it long. Okay, and we'll say long over here also. And try to run this one. So you got something. But if you go to somewhere around 34, I think this will also die. Okay, 34 is working. Let's try 40. So you again got a negative number. Now the next variable we can use is big integer. So if you want to get a factorial of a very big number, we can use something called big integer. Let's do that. Replace all floats with big integer at the first step. Sorry, all long. We'll come to this line. Okay. Now this will be integer dot value of. So if anyone asks you this question in an interview or something, you should safely write the program with int, because it's more to check with the logic rather than anything else. So I think this is almost done. Similarly, we will update the value. One is assigned in this way, in big integer. All right, now let's just check how it works. for a factorial of 40. So it gives you a proper result over there. This is how we, using this big integer, you can do it for quite big numbers. And so thank you very much. Please subscribe, please share, please like, please put in your comment or comments so that we can improve. Thank you very much.